Local AI Speed Wars. Local AI Speed Wars DFlash just landed in llama.cpp, and the benchmarks deserve attention rather than hype. The technique pairs a block diffusion drafter with the main autoregressive model, allowing roughly 8 tokens to be speculatively decoded in parallel. On Qwen 3.527B running on an RTX 3090 at 36K context, the tester measured a 4.44x speedup, from around 440 tokens per second stock to 1,950 with DFlash engaged. The gains scale with context length. At short prompts, the overhead barely pays for itself, but at 36K tokens, the KV cache penalty on standard generation is severe enough that speculative drafting dominates. Prior coverage of DFlash on Apple Silicon via MLX reported 2x gains on similar models, so the llama.cpp implementation is delivering on the architecture's promise rather than inventing new magic. Ollama 0.31 brings multi-token prediction to Gemma 4 on Apple Silicon, a quieter but broadly useful speedup. MTP works because the prediction heads are already baked into the model weights during training. The runtime just needs to exploit them. For M4 Pro users, this means measurable throughput gains without touching quantization or swapping models, the kind of improvement that compounds across every session rather than headline grabbing on a benchmark chart. It also signals a broader trend. Model authors are shipping inference optimizations as trained-in capabilities rather than leaving them to runtime hacks. The hardware side of the speed war got more interesting. AMD's Ryzen AI Halo Dev Kit arrived at LTT Labs for a full review. At $4,099, it sits in an awkward price band, more than a Mac Studio, less than a dual GPU workstation. But its 128 GB of unified memory is the real pitch. That unified pool means you can load 70 B-class models that simply do not fit on consumer discrete GPUs. The Max Plus 395 delivers 256 GB/s memory bandwidth, enough to keep a 70B quantized model generating at practical speeds. BKC playbooks ship with the kit for ROCm setup, but the software story remains AMD's persistent weakness. Reviewers noted rough edges in driver stability and VLLM compatibility that NVIDIA users never encounter. Community reception was split. Some compared it favorably to NVIDIA's pricing on equivalent VRAM. Others questioned whether ROCm is mature enough to justify the investment when a Mac Studio with 192 GB just works. Then there is Huawei. A benchmark showing an Ascend 910C running DeepSeek V3 at speeds competitive with NVIDIA data center parts drew genuine surprise from a community that had largely written off Chinese AI silicon as export-controlled and software-starved. The numbers are real enough to take seriously, but the questions that matter. Developer tooling, availability outside PRC, inference framework support remain unanswered. This is genuinely new territory for the local AI community, and the discomfort in the thread is palpable. Models Go Multimodal. Models Go Multimodal. NVIDIA's Nemotron Audex 30BA3B marks a deliberate architectural choice. Audio is not a pre-processing step, it is a first-class token type inside the transformer. The model uses a mixture of experts architecture, with 30B total parameters, but only 3B active per forward pass, keeping inference costs manageable while processing raw audio waveforms alongside text tokens in a shared sequence. For tasks like meeting summarization or spoken Q&A, this is the difference between analyzing what was said and understanding how it was said. Temporal grounding, tone, hesitation patterns, all available to the model without lossy transcription in the middle. Google's Gemma 4 technical report fills in the details behind the family's strongest release. The 27BA4B MOE variant hits a sweet spot for single GPU deployment while delivering multimodal capabilities. Vision, audio understanding, and strong coding performance. Under an Apache 2.0 license, community response focused on two things: benchmark performance that competes with models twice its active parameter count, and the practical discovery that quantized variants NVFP4W4A4 run comfortably on consumer hardware without the quality cliff that plagued earlier generations. The ecosystem matured fast. Parler demonstrated a fully on-device multimodal app pairing Gemma 4 with Kokoro TTS at 1.53 second end-to-end latency on an M3 Pro laptop. Hugging Face and Cerebras turned Gemma 4 into a real-time voice pipeline, and the latency numbers explain why it matters. Cerebras inference delivers hundreds of tokens per second, which means the full cascade. Whisper transcription, Gemma 4 reasoning, TTS synthesis, completes fast enough for natural conversation. Sub 200 milliseconds first token latency makes this feel like talking to a person rather than waiting for a computer. The blog provides reproducible code for the full cascade, which matters more than the demo. Anyone with API access can stand up a conversational voice agent without specialized hardware or vendor lock-in. World Models and Embodied AI. World Models and Embodied AI COMAP introduces a training loop where the world model and the agent policy evolve together through on-policy self-distillation, the standard approach. Train a world model on demonstrations, then train a policy against it. Suffers from distribution shift. The world model learned expert behavior it never sees during policy execution, so it provides unreliable predictions exactly when the agent needs them most. COMAP's fix is future-aware reflection. The world model predicts consequences of the agent's actual policy. The policy adapts to the world model's actual predictions, and both improve in tandem. Results on ALF World, WebShop, and Science World show consistent gains over fixed world model baselines. The paper is dense, but the core insight is clean. World models trained off policy are a leaky abstraction, and coevolution is how you seal the leak. NVIDIA's SpatialClaw reframes spatial reasoning as code generation rather than coordinate prediction. Instead of asking a vision language model to output raw positions, SpatialClaw has the model write short programs that express spatial relationships. Place the cup to the right of the plate, 10 centimeters from the edge. Across 20 benchmarks, this code-as-action interface improves accuracy by an average of 11.2 points. The result makes sense if you think about it. Coordinate systems are arbitrary and models struggle with them, but spatial language is exactly the kind of compositional reasoning transformers handle well. The VLM never needs to learn coordinate systems. It writes programs that already encode them. LeRobot v0.60 is the most ambitious release yet from Hugging Face's robot learning framework. World model policies let robots plan by imagining future states before acting. A reward model's API replaces handcrafted reward functions with learned preferences. Dagger interactive deployment closes the gap between demonstration and deployment by feeding human corrections back into the policy in real time. FSDP makes training these models feasible on multi-GPU setups without custom distributed training code. Each feature solves a different piece of the sim-to-real transfer problem, and the framework is open source with real documentation, which in robotics remains the exception rather than the rule. AI security and interpretability. AI security and interpretability. Anthropic's Jacobian lens may be the most significant interpretability advance since sparse autoencoder features. The Jacobian matrix of a neural network layer captures how small perturbations in the input propagate to the output. A linear map of what the layer computes locally. Analyzing these matrices across layers lets researchers trace how information transforms as it flows through the network, where features are created, combined, and destroyed. The practical payoff is a principled mathematical framework for understanding model internals, replacing the post-hoc feature visualization that has dominated interpretability work. For safety researchers, this means identifying where a model encodes dangerous capabilities not by searching after the fact, but by watching them form during forward passes. Reuven Cohen's editorial frames it as infrastructure, not research, the kind of tool defenders actually need. On the adversarial side, a paper on molecular graph neural network backdoors reveals how domain-specific constraints break generic defenses. ChemBack defines backdoor attacks that respect chemical validity. The poisoned molecular graphs are still valid molecules, so defenses based on detecting unusual graph structures fail completely. ChemGuard responds with an admission-based defense that filters inputs through a chemistry-aware plausibility check before they reach the model. This matters because molecular GNNs are deployed in real drug discovery pipelines, and the standard ML security playbook assumes data points live in a continuous vector space where outlier detection works. Chemistry has hard structural constraints, valence rules, ring strain, bond angles, that an attacker can exploit precisely because generic defenses do not encode them. Agentic coding and developer culture. Agentic coding and developer culture. The AI Builder Club's open source skills repository and a detailed agentic workbench post both point at the same shift. Developers are assembling their own orchestration layers rather than waiting for vendors to ship them. The skills repo defines modular capability specifications that coding agents can invoke, structured as composable units rather than monolithic system prompts. The workbench post walks through a personal setup, coordinating multiple AI assistants through custom workflows, with the revealing observation that the orchestration itself is becoming the primary engineering artifact, not the code it produces. A 608-page Dreamlab thesis, Vision Flow, attempts the bigger framing. Its central argument. AI collapses a 2,000-year coordination tax, the overhead of aligning human effort across organizations. When intelligence is cheap, the organizational forms that evolve to manage expensive human coordination become deadweight. The thesis proposes 3 successor models: autonomous pods, small teams amplified by AI, network guilds, expertise sharing across organizations, and platform cooperatives, democratically governed AI platforms. The predictions are speculative, but the question is right. Every major organizational form in history emerged from a specific coordination constraint, and LLMs are dissolving several of those constraints simultaneously. Meanwhile, a Reddit thread captures the human cost of the transition with uncomfortable clarity. Does anybody else feel like their ability to write and read code is going down day by day? The community consensus is split but instructive. Syntax memory fades, yes, but it was never the valuable skill. The top analogy. A farmer complaining that a tractor makes hand-tilling strength obsolete is glib but directionally correct. The more nuanced responses cut deeper. When I feel myself getting lazy, I make myself write the acceptance criteria and one failure case first. If I cannot do that, I am probably outsourcing the thinking, not the typing. Prior coverage tracked the same tension through Durametrics and senior engineers arguing that agentic tools are seniority biased. The tooling professionalizes. Organizations have not yet figured out what the new job description actually is. Infrastructure at scale. Infrastructure at scale Cloudflare's Meerkat is their internal implementation of Paxa, a consensus algorithm designed for the exact environment where Raft and Paxos fail. Wide area networks with unpredictable latency and no stable leader. Traditional consensus assumes a leader that can coordinate rounds within tight timeout bounds. On a CDN spanning 300+ cities, that assumption breaks constantly. Leaders time out, new elections disrupt in-flight transactions, and throughput collapses during the handoff. Paxa sidesteps this by running leaderless. Every node can propose, and the algorithm combines optimistic and pessimistic paths to reach agreement without timeout-driven failure modes. The Cloudflare post walks through both the theoretical foundations and the engineering trade-offs of deploying it at global scale for configuration propagation and distributed KV coordination. SkyPilot and Hugging Face jointly tackled the other infrastructure lock-in, egress costs. Most AI teams hold GPU capacity across multiple clouds. Reserved H100S on AWS, a cluster on GCP, maybe an on-prem rack. But their data lives in a single cloud bucket. Moving a model to wherever GPUs are available means paying egress $0.09 GB on AWS, which in practice pins workloads to whichever vendor holds the data and leaves reserved capacity elsewhere idle. The integration makes Hugging Face storage a first-class SkyPilot backend with zero egress fees. Models stay on the hub, SkyPilot schedules compute across 20+ clouds, and lazy fuse mounts pull only the bytes actually accessed. ZET-backed content-defined chunking means checkpoint uploads only transfer changed chunks. Re-uploading an 8.43 GB checkpoint already stored took 8 seconds versus 24 for the initial upload. Storage stops deciding where you run. For teams juggling reserved capacity across 3 or 4 vendors, this is the plumbing that turns multi-cloud from a procurement strategy into an operational reality. Privacy, policy, and open source governance. Privacy, policy, and open source governance. Flipper Zero's development blog is a quiet signal worth reading closely. The team outlines a future focused on open protocol analysis, education, and legitimate security research. A deliberate repositioning against the hacking gadget narrative that has drawn regulatory scrutiny in multiple jurisdictions. The tension is real and unresolved. The same capabilities that make Flipper useful for security professionals make regulators nervous, and no amount of branding resolves the dual-use problem when legislators do not distinguish between tools and intent. A university professor pushed a batch of PRs to make Open Web-wide WCAG 2.1 AA compliant. Keyboard focus, skip to content links, dialogue roles, contrast ratios, accessible names for icon-only buttons. The motivation is ADA Title II, Section 508. Any software used in university classes must meet minimum accessibility standards, and most AI tools fail basic audits. Each PR is scoped to a single WCAG criterion and tested. The implicit point is sharp. The AI tool's community builds for power users and ignores the legal and ethical obligation to make interfaces usable by everyone. Accessibility is not a feature request. In educational and government deployments, it is a compliance gate. The biggest policy story this week is the EU chat control saga, and the procedural details matter more than the headlines. Chat Control 1.0. The temporary e-privacy derogation that let providers voluntarily scan private messages. Expired April 4th after Parliament rejected its extension 311 to 228. That should have been the end. Instead, the Council is attempting an unprecedented fast-track revival. A formally new regulation with identical content pushed through expedited procedure. Parliament voted last week to skip committee review entirely. The binding vote is Thursday, July 9th, and the procedural trap is brutal. An absolute majority of 361 MEPs is needed to stop it. Abstentions and absences count as votes in favor. Meanwhile, Chat Control 2.0. The permanent CSIR mandating CSAM detection remains deadlocked after 5 failed trilog rounds, with encryption scanning as the unresolved red line. The Council's own legal service stated that voluntary suspicionless scanning constitutes generalized surveillance incompatible with Charter Article 7. Both fights are live. Both depend on whether enough MEPs show up Thursday, and the temporary law being resurrected through the back door while the permanent one remains on the table is exactly the kind of procedural maneuver that erodes trust in EU legislative institutions.